Hello there, welcome to another video in our exponential section. This one is a throwback to our solving different equations from first semester, but we figured we'd just review this anyhow. So we're looking at exponential equations with different bases, and what we're talking about is that we've got exponents and we have a variable in the exponent. So take a look at our example here. We have 36 to the 3a power equals 6 to the third power. What we need to do with this is, like many other things we do in algebra, is manipulate the equation to look like something we already know. So what we're going to do with the 36, not necessarily the 6 on the other side, but 36, is we are going to rewrite it. And you're going to rewrite that as 6 squared. And you may ask, why are we writing 36 as 6 squared? Well, if you look to the right of the equal sign, we have 6 cubed, or 6 to the third power. We are going to get it to have the same base. So take a look at what happens next and see, let it all kind of digest. So we have the 3a, and we have it equals 6 to the third power. And then, oh, I don't know where he is.
Oh.
Yeah.
I don't know, I thought since you're like a math teacher, you know where all the math teachers are all the time?
Let me look in my head. No, he went out of my radar.
Oh.
That's Yamara. Yamara, say hi. You're on the video. Say hi.
Say who?
To the video. I'm making a video. Whatever. Hi, that's Yamara. She says hi. I'm sure they're saying hi back.
Sorry.
Oh, it's okay.
Listen to Frank, guys.
You hear her? Listen to me. Okay, keep listening. Now we have 6 to the second power raised to the 3a power. Now, well, you tell me what we used to do. Yes, you're correct. Multiply them together. So we take the 2 and multiply to 3a, and now you have 6 to the 6a power. And on the right-hand side, we still have 6 to the third power. So now, if we look at this, we have the same bases on each side of the equal sign. So what we have on the left is equal to what we have on the right, which is the most powerful symbol we have, the equal sign, telling us that two things that that don't look alike are actually similar in some way, shape, or form. In this case, our value is the same. Now, if our bases are the same, in order for this whole thing to be equal, our exponents must be the same as well, or equal. So what we're going to do, yep, there's the equal sign. Let's, I'm going to put it therefore because I'm not necessarily making the bases of 6 disappear. I am just taking the exponents and saying that they must be equal. So therefore, if those two terms are equal, their exponents must be equal as well. So 6a must equal 3. And then from there, we can solve for a. You do your normal thing. You take that 6 and, divide it, and our a is equal to 1/2. Okay, let that sink in. Take a nice deep breath. Take a look at all of that. What we're doing is isolating that a. So, like, simply we start manipulating the bases, taking them out of the equation. Not traditionally, but we're kind of moving them away so we can look at the exponents themselves. Let's see if that makes sense. Let's try that with another question. So you try this. I'm going to put this on there on the board, and you give it a shot. Press pause while the question's up there, and then press play when you're ready to see it solve for it. So we have 625 to the negative 2n power. All of that equals 125. I'm going to press. You should press pause here, give it a shot, and see what happens, and then press play when you're ready. Okay? All right. Press pause. Okay, welcome back. So our bases are 625 and 125. Our goal here is to make those bases the same. We'll rewrite them. So 625 and 125 are variations of the number 5. So 625 and 125 have the same base of 5. So 625 can be changed to 5 to the 4th power. It's not that they have the same base of 5. They can be changed, so there is a base of 5. So 625 can be changed to a base of 5 to the 4th power, because 5 times 5 times 5 times 5 is equal to 625. 125, so if you're getting this, some of you might think, oh, well, 125 must be 5 to the, yes, you're correct, third power. Bam. So we write 5 to the third power there. So now we have the same bases on both sides of the equal sign. We combine our exponents. We rewrite the right side. And now we have our bases equal, which must mean, logically speaking, our exponents must be equal. So I put therefore to separate them out, negative 8n must equal 3, and now we can solve for our n. Divide by negative 8, and n is equal to negative 3 over 8. Don't keep that negative sign in the denominator with the 8. That whole term is now negative. So it's like positive 3 divided by negative 8 would give you a whole term that is negative, and the term itself is 3 over 8. And that's your answer boxed in blue. So we'll be reviewing this, going back to what we did first semester, and now applying more of our exponential expertise. Oh, you like that? Your exponential expertise to solve these equations. All right, we'll see you all in the next video. Thank you very much for listening.